Hello, my dear students. Welcome back to your favorite and India's most affordable learning platform, Physics Wala. So, in the last session of motion in a plane, we discussed the relative velocity in terms of 2D, right? So, where we covered the number of numericals related to the Rainman problems or rain umbrella questions, and then river swimmer or riverboat questions. Okay, so whatever the concepts that I covered through the questions, so those are more than sufficient for your any competitive examination. Okay, so just take the previous class as the reference and solve more questions on those topics, whether you are able to solve them or not. Just analyze yourself. Okay, so that's very important. So in today's session I am going to start the projectile motion, the lecture 6 of your motion in a plane. So that's going to be the projectile motion, which is again a important topic for your competitive examinations, whether it's JEE or NEET or WB-JEE or BITSAT, anything, any competitive exam you write. So the projectile motion is very important. Okay, chalo. So without wasting much time, let's get into the today's topic. So for the next 1 hour or 1.5 hours, just be with me, avoid all the disturbances around you guys, and at the end of the lecture, prepare your own short notes. That's very important. Okay, chalo. So first, so hope you guys already having the basic knowledge of the projectile motion. So throughout my lecture, what I do is the projectile path. See, what is projectile path first? So till now, in the motion in a straight line, we have studied the body's motion in 1D, one dimension, right? So when you throw body, so like this, so straight. So then it goes in y direction, again comes back in the y direction. Yes or no? Only one dimension motion, that's in y direction. Or else when an object is moving or a car is moving on a straight road, so it started from point A and reached some point B. So the car is making again 1D motion. The car is not going in A, right? It's not moving. So till now whatever we have studied, that's the motion in 1D, one dimensional. So that too, so the motion under free fall, so that also we have seen, motion under gravity, right? So here projectile motion is nothing but, so whenever you have thrown some object with some angle, let's suppose whenever you have thrown with some angle like this, so then what happens? The body covers the path like this. Just imagine the general thing. So when you throw a stone like this, so then what happens? The stone makes this path. So this path is nothing but the projectile path. So where it covers some distance in the y and it covers some distance in the x. So that's a 2D motion of the body. Okay, chalo. So that's what I am doing. So the total parabolic path, so whenever you throw a object from here with some initial velocity u, so then it reaches some other point here, so then so body is moving in the x direction and body as well as moving in the y direction, right? So every projectile path, so I am going to divide it in two parts. So one is how much, like how it is moving in the x direction and how it is moving in the y direction. So this is the easiest process you can solve the projectile motion question. So I am going to divide the parabolic path of the projectile so into its vertical motion as well as its horizontal motion. So first see here, so this is a vertical motion and this is a horizontal motion. So this is the horizontal motion, sorry. So see here, so when you throw a body with some velocity u at an angle theta with respect to the x-axis, so then the body covers the path like this. So and then at some point it reaches some maximum height. So that is known as the capital H, which is nothing but the h, right? And then body you have thrown from here and then so the body has reached here. So the total distance covered in the horizontal way, see here from here to here, the total distance covered is called the range. From here to here, it's called the range, the total distance covered. Yes or no? Next. So this is called maximum height, this is called range. And from here to here, whatever the time that has taken, so that is called time of flight. Whatever the time taken from here to here, the total time is called time of flight. Basic terminology I am talking about. And then you have thrown the body with some velocity, initial velocity u, so with some angle theta. So this initial velocity will now have two components. What are the two components? So one is the horizontal component, that is u cos theta, and So one is a vertical component u sin theta. Already we have seen it in the vectors, right? So wherever the theta is there, that side cos component will come. U cos component this side, u sin component this side. Yes or no? So this is about the basic projectile path and its terminology. Now the thing is, so let's write, so it's vertical motion and it's horizontal motion, just I am considering. So it's vertical motion and horizontal motion. So which speed is responsible for the vertical motion here? The u sin theta is responsible for the vertical motion, yes or no? The body is traveling in the y direction due to the speed in y direction. So what is the speed in y direction? Its initial velocity in the y direction. U sin theta is responsible for the motion in a y, right? So that's why its initial velocity in the y direction is u sin theta. And then after reaching certain point in the y direction, so at some point its velocity will become 0, yes or no? So in the vertical direction, at some point, so its velocity will become 0 here in the vertical direction. So the velocity in the y is 0. The velocity in the y is becoming 0. So and then acceleration due to gravity is always negative. It always acts downward. When the body is going up, acceleration due to gravity always acts downward. That's why ay is equals to minus g, right? So these are the things that are there in the vertical motion. So its initial velocity in the y is u sin theta, and then its final velocity in the y is going to be 0, and then its acceleration is going to be minus g in the y direction. So now coming to the x direction motion. So this is the x direction motion. So the body is moving from this point to this point. So which speed is responsible for the horizontal motion? Obviously the horizontal speed. So what is the horizontal speed here? So the horizontal speed, that is u in the x direction, it's going to be u cos theta. U in the x direction, it's going to be u cos theta. And then the total distance covered in the x direction, the total distance covered in the x direction, it's going to be r. Yes or no? The total distance covered in the x direction, it's going to be r. See, so throughout the body's motion, so its velocity becomes constant. Throughout its horizontal motion, its velocity becomes constant. So that's why the u cos theta is always constant. The u cos theta is always constant. So that's why its acceleration in the x direction will be 0. Throughout its motion, the body the body maintains the same horizontal velocity. Throughout its motion, the body maintains same horizontal velocity, which is nothing but u cos theta. So if the velocity is not changing, if the velocity is constant, we know that its acceleration 0, right? What is acceleration? dv by dt, right? So if the velocity is constant, differentiation of the constant is going to be 0. That's why acceleration is going to be 0. So these basic things while solving the projectile motions are very, very important. Okay, so how the body behaves in the vertical motion and in the horizontal motion, and combinedly this plus this gives rise to this. Okay, clear? Understanding? Now let's understand the projectile motion more detailed way. See here, as I discussed earlier, so let's suppose initially, let's suppose you thrown the body with some velocity u. Okay, so at an angle theta, so here the body will have the velocity u cos theta horizontally, and then so here its velocity here it's going to be u sin theta. Here its velocity is going to be u sin theta initially. So now, as I said earlier, its horizontal component of the velocity will never change. U cos theta, 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 and u cos theta. Everywhere its horizontal velocity is going to be constant. Everywhere its horizontal velocity is going to be constant. So nowhere it changes from starting to ending point. But its vertical velocity, see here. So here vertical u sin theta is more. So as it goes up, you know that the speed decreases in the vertical motion. So here u sin theta, and here it decreases, and here it decreases, and here at the highest point, at maximum height, so the Vy will become 0. Vy will become 0. So don't say that at the highest point of the projectile, the body's velocity is 0. Don't say that, because the body's vertical velocity is 0, but horizontal component still exists. See here, the horizontal component still exists. So at the maximum height Vy is 0, but the Vx is u cos theta. If somebody asks you what is the velocity at the highest point of the projectile motion, don't say 0. Its vertical velocity is 0, horizontal component is still existing, which is going to be u cos theta. So that's why if you write the velocity at the highest point, so only this component exists in the vector form. If I write u cos theta will exist, only u cos theta will exist. Clear? Understanding? So there is no vertical component. So this is important. And one more point that I can write here. So the u cos theta remains constant throughout its motion. U cos theta is constant throughout motion of the body, right? So that's why I can say the Ax is going to be 0. This is one more point. And one more thing, so the Vy, it decreases initially, and then Vy becomes 0 at Hmax, at maximum height. Then while coming down again Vy increases. So that means, let's suppose its velocity initially here u sin theta vertically. So here let's suppose some v1, here let's suppose some v2. So here it is 0. Again whatever the velocity v2 is there, here it will be there. Here whatever the v1 velocity is there, here it will be there. Whatever the u sin theta is there, here the u sin theta. So that means it follows the symmetry. So it follows symmetry in 1D. It follows symmetry in y direction. It follows the symmetry in y direction. Clear? Understanding this point, everyone? Right? Chalo, next. So the next point, that is, so fine, Vy becomes 0, Ax 0, yes, fine, yes. So these are the points that you should remember related to the projectile motion. So at some point, if somebody asks you what is the velocity, let's suppose here somebody asks you what is the velocity. So then what you do is find the x component here and find the y component here. So x component I cap, y component j cap. So that also we'll see. Just I am giving the just brief idea. Okay, now clear this point. Chalo, let's move further. So what's the question says? See here. The first question, the speed of a projectile at its maximum height is half of its initial speed. So the angle of projection is, see here. So what's the question says? So see here. So a body, if the speed of the projectile at its maximum height is half of its initial speed. Consider the body is thrown with some initial velocity u, so with some angle theta. So then it follows this path, let's suppose. At its maximum height is the speed of a projectile at its maximum height is half of its initial speed. So what is the initial speed? The initial speed is u, right? So I can say what is the initial speed, which is equals to u. So now speed at half of its maximum height. So what is speed at half of its maximum height? So which is going to be u cos theta at half of its maximum height. See here, sorry, speed at maximum height. Speed at maximum height. So which is going to be u cos theta. The speed at maximum height is going to be u cos theta. So then I can say that here, what I can write simply. So they are saying the projectile speed is half of its maximum height, half of its initial speed. So the u cos theta, they are saying that it's equals to half of its initial speed. Initial speed is u, half of its initial speed means u by 2. So which is equals to speed at maximum height. So then I can say u cancel, cos theta is equals to 1 by 2. So then theta is equals to 60 degrees. That's it. So the theta is equals to 60 degrees. Option A is the correct one. Clear? Done? Chalo. So now let's move further. So what's our next question says? The velocity of the projectile at the initial point A is, so the velocity at this point, at A point. So the velocity at A is given as 2I cap plus 3J cap. So meter per second. So its velocity at point B. So we need the velocity at point B. So at point B, this is the point B, right? So at point B, the horizontal velocity remains same, right? So the horizontal component 2I, it remains same. But what about the vertical one? So the magnitude remains same, it just reverses. Yes or no? Here the horizontal component is this here and vertical component is this one at point A. So now at point B, it's going to be horizontal component remains same, 2I cap. Vertical component magnitude remains same, but the direction reverses. So what's the direction here? So that's it. So reverses means just keep the symbol opposite. So 2I minus 3J meter per second. So 2I minus 3J meter per second. Clear? The simple questions. So now, so how do you find the resultant velocity and inclination with the horizontal at some point? So see here. So here, just understand the procedure first. So let's suppose you thrown the body from here and then it follows this path. Okay. So now, if I ask you what is the velocity at this point, you say it's going to be simply u cos theta, vertical component is not existing. And here if I ask you the velocity at this point, u cos theta horizontally, u sin theta vertically, right? So but if I ask you at some random point, okay, so if I ask you at this random point, so shall I say that at this point, so the body has covered some distance x in the x direction, and then at the same point the body has covered some distance y in the y direction to reach this point. The body has covered some x distance in the x direction and some y distance in the y direction. Okay, so now I have to find what is the velocity at this point. I have to find what is the velocity at this point. So one thing is for sure, that is u cos theta, if it is the initial velocity, the horizontal component is not going to be changed, right? So u cos theta here. So that means here at this point we have got the horizontal component of the velocity. So let's suppose, so divide this projectile motion into two parts, x direction, y direction. So now in the x direction, the ux is equals to u cos theta, ux is equals to u cos theta, and then ax is equals to 0 because horizontally the velocity will not change, acceleration is going to be 0. So then let's suppose the body has taken, so time t to reach this point, so horizontally to reach this point, let's suppose time taken t. So then I am finding the velocity in the x direction. So v is equals to u plus at equation I am using, ux plus axt. So what is ux? U cos theta plus this ax is 0, so this is going to be 0. So therefore vx is equals to u cos theta. Vx is equals to u cos theta. So vx is equals to u cos theta, right? So then now, so this we already know, no need to go for the derivation also, because horizontally the velocity will not change, u cos theta here, u cos theta here. But vertically, what is its velocity here? Obviously, if it is u sin theta initially, so obviously it will be less than that here. Yes or no? Because the speed decreases while it's going up and becomes 0 at the maximum. Now, so in the y direction, its initial velocity, I know that it's sin theta, and then ay is equals to minus g, and then so the time taken from here to here, let it be t. So then I am using the equation v is equals to u plus at. So vy is equals to uy plus ayt. So what is vy? So vy, so we have to find uy, initial velocity in the y direction is u sin theta, ay minus g, time taken t. So therefore, so the velocity in the y direction, it's going to be u sin theta minus gt. Initial velocity is u sin theta here. Initial velocity is u sin theta. Obviously, after some time t, its velocity decreases by minus gt times. So at this point, now if I write what is the velocity at point P, so shall I write like, so the horizontal component is u cos theta I cap, and the vertical component is u sin theta minus gt j cap, u sin theta minus gt j cap. So u cos theta I cap plus u sin theta minus gt j cap in the y direction. That's it. So if they ask you what is the velocity, what is the speed at that point, simply the magnitude square, right? U cos theta whole square plus u sin theta minus gt whole square. This is the velocity at point P. Yes or no? So, and if they ask you what is the angle of inclination at this point, here the angle of inclination is theta. Obviously the angle of inclination changes as the body is projected. Yes or no? So here I can write the tan alpha. What is tan alpha here? So if you parallel shift this one, so this is going to be velocity in y by, so the velocity in the x, the simple thing. So the tan alpha is equals to vy by vx. That's it. So you can find the angle of inclination at some point, at random point on the projectile motion. If you have to find what is the velocity at that point and what is the angle of inclination at that point, so you can easily do by this procedure. Okay, so not only remembering the formula, understand the procedure, because so they might ask you at some point or at this point, so you can find easily. Clear? At any point you can find if you know the procedure. So let's take the simple question. What's the question says? A projectile is thrown with a speed of 100 meters per second, making an angle 60 degrees with the horizontal. So find the time after which its angle of inclination with the horizontal is 45 degrees. Let's suppose, so this is a body. Consider this is a body, so which is thrown like this. Okay, so chalo. So first, a projectile is thrown with a speed of 100 meters per second, making an angle 60 degrees. So initially its velocity is 100 meters per second and then making an angle 60 degrees. So with the horizontal, find the time after which its inclination with the horizontal becomes 45. So let's suppose after some time, so the body horizontal velocity is like this, so and the vertical velocity let it be. So here the angle of inclination becoming 45 degrees. So after how much time the angle of inclination changes from 60 to 45 degrees? That's what they are asking. Okay. So the first thing is, here I'll be having two components. So one is the ux. Ux is equals to u cos theta. So what is u? 100. 100 into what is cos theta here? Cos 60. 100 into, so cos 60, 1 by 2. So which is here, so 50. Ux is 50 meter per second. And similarly we'll be having, so the uy, which is u sin theta. So what is the initial velocity u? So which is 100 into sin theta, sin 60. Sin 60 is root 3 by 2. So this is going to be 50 root 3. This is going to be 50 root 3. Okay, so now the thing is, so let me use here the tan alpha formula. We know that the tan alpha is equals to vy by vx. So tan alpha, here alpha is given as 45 degrees. So tan 45 is equals to vy by, so here the vx remains same, whatever the x component that we got 50, so will be same throughout its motion. So therefore here the vx is also equals to 50. Yes or no? So therefore in place of vx I am writing 50. So tan 45 is 1, which is equals to vy by 50. So from there the vy is equals to 50. From there the vy is equals to 50. Yes or no? Clear this point? So we have got the velocity in y direction. See, after reaching this point we have know what is in velocity and what is vertical velocity, right? So similar, now I can do simply its initial velocity uy is 50 root 3, and then its final velocity in the y direction is again 50, right? So and then what is ay? Ay is equals to minus g, which is equals to minus 10. So can we use simple equation vy is equals to uy plus ayt? So the only unknown is time here. So vy is 50, uy 50 root 3 minus 10 into t. That's it. So now I can write 50 minus 50 root 3 by, so 50 minus 50 root, let's write reverse because t we have to bring it to this side, right? So then 10t is equals to 50 root 3 minus 50. So from here t is equals to, so 5 root 3 minus 1. Yes or no? 5 root 3 minus 5, 5 root 3 minus 5, or 5 into root 3 minus 1. 5 into root 3 minus 1. Option A is the correct one. Clear? Got it this point? Sure. So next, so what is the time of flight? So the time of flight, see here, the time of flight is nothing but the time taken from initial point to reach the final point. Okay, so what I am doing is, let's consider this is the initial point. I am considering the body's motion from here to here. Okay, from here to here, this is called time of ascent, and from here to here it's called time of descent. So we know that the projectile motion follows a symmetry in y direction. Yes or no? So how much time, whatever the time that it takes from here to here, the same time it takes from here to here. So that's why what I am doing is, let's consider O to A motion simply. OA up to OA. So that too, let's take y direction. Let's take y direction. So what is the initial velocity in the y direction? Uy is u sin theta, and then ay is minus g. Yes, so let the time taken t is equals to t there, and then so can we use simply vy is equals to uy minus ay plus ayt. So vy, the final velocity is 0 if it reaches this point. Uy, what is uy? U sin theta, ay minus g t. So from here the t will be equals to simply u sin theta by g. See, do the basic calculations bit faster. That's okay. So this is the time taken from here to here, right? So but we need the total time of flight. So what is the total time of flight? So the time of flight will be equals to the time of ascent plus time of descent. So and then we say that the time of ascent is equals to this one, and which is also equals to time of descent, because the motion, the y direction symmetry, right? So that's why, so time of ascent u sin theta by g, and time of descent u sin theta by g. So which is going to be 2u sin theta by g. Yes or no? So this is going to be 2u sin theta by g. So this is the total time of flight. So 2u sin theta by g. Clear this part, guys? Everyone? Chal. So let's move further. So now what is the maximum height reached by the body from here to here? So that's called the maximum height. Okay, so again I am considering, let it be A, let it be B. So OA up to OA, and then I am taking the y direction motion. I am considering the y direction. Just we are deriving the formulas, that's it. Okay, so what is the initial velocity in the y direction? U sin theta. So what is acceleration in the y direction? Minus g. So what is the distance covered in the y direction? So y direction, the distance covered in OA is this one, right? So h, right? So then simply use the equation v square minus u square is equals to 2as. V square minus u square is equals to 2as. V square, so the final velocity in the y is 0. So this is 0 square minus u square, uy square, u sin theta whole square is equals to 2 ay minus g sy minus h. Okay, from here, so u square sin square theta is equals to 2gh. So we need h here. So the h is equals to u square sin square theta by 2g, or u sin theta whole square by 2g also you can write. So therefore from now you have to remember the maximum height reached by a projected body, it's going to be u square sin square theta by 2g. U square sin square theta by 2g. Okay, clear this part? Chalo. So now the other one is the horizontal range. So what is the distance, total distance covered from here to here? So I am taking, this is O, let it be A, let it be B. So let's take the horizontal motion from O to B. Why? Because the range is in the horizontal direction, right? From here to here we need the total distance. So that's why the ux is equals to, so we know that u cos theta, and then ax is going to be 0. And what is the total time taken by the body from here to here? what is the total time taken by the body from here to here? The total time taken is nothing but the time of flight. Yes or no? What is the time of flight? 2u sin theta by g. So now simply use the Sx is equals to uxt plus half axt square. Obviously I can say that this whole term will become 0 because ax is 0. And then Sx, which is nothing but range, is equals to ux, u cos theta into, so time of flight, what is time of flight? So t 2u sin theta by g. So 2u sin theta by g. So we can write this as 2 into u square sin theta cos theta by g, or else you can also write it as u square into 2 sin theta cos theta, which is nothing but sin 2 theta. U square I am writing first, then 2 sin theta cos theta, which is nothing but sin 2 theta formula. So which is this one. Okay, so from now the time of flight you have to remember it as u square sin 2 theta by g. What is sin 2 theta? 2 sin theta cos theta. Done. So these are the three important derivations. So the horizontal range, maximum height, and time of flight. Okay, so this is not time of flight, this is a horizontal range, r. Alright, chalo. So that's what I wrote here. The time of flight is 2u sin theta by g. So this you can also write it as 2u sin theta is nothing but initial velocity in the y direction. So 2uy by g. And then u square sin 2 theta. So shall I write this as 2 into u sin theta into u cos theta by g. See, this u square I am writing u into u. Sin 2 theta is 2 sin theta cos theta. So 2 I wrote it aside, and then u sin theta, u cos theta I wrote. If you are getting confused, just let me expand this one. So this one u into u I am writing u square. Sin 2 theta formula I am writing 2 sin theta cos theta. Okay, so by g. So then what I am doing is, let's write 2 aside and put one u in front of cos, and then one u in front of sin, u in front of sin, u in front of cos by g. So now u to u cos theta ux, u sin theta uy by g. That's it. So then here this is u square sin square theta by 2g, which is nothing but u sin theta whole square by g. So which is uy square by g. Shall we write? So this is the simple way to remember the three formulas. Understood, guys? So these importance you'll understand when we deal the projectile motion and inclined plane. So in the 8th lecture of motion in a plane, we are going to discuss the motion in an inclined plane. So there you will understand the importance of these. Okay? Chal. So can you take this question as homework, guys? This is a homework 1 question, which is a very simple question, which is based on the formula. That's it. They gave the initial speed and they gave the theta. So and then simply you have to find what is maximum height, what is time of flight, what is horizontal range. So what is time of flight, what is h max, direct formula based question, and what is range. So just comment your answer. Okay, simple question, just substitution. Yes, this question also. So see here, this is 5 I cap, this is 10 j cap. Okay, so u is equals to, this is 5 I cap plus 10 j cap. Just write like that. Okay, find the time of flight, maximum height, range. So the same question, take it as a homework 2 and then comment your answer. What is time of flight, what is h max, and then what is range. So just comment your answer. Clear? Understood, guys? Chal. So I'm going to wind up here. So in the next session, so we'll discuss the remaining part. Okay, so chalo. So it's going to be a very short lecture today. So then projectile motion, I'm going to cover one more lecture. Okay, so the way there we'll discuss what is the relation between horizontal range and maximum height. So all these things we'll discuss in the next class. And then one more lecture of projectile motion also there, where we'll discuss the motion and the projectile motion on inclined plane. Okay, so till then keep studying. All the very best. Bye, guys.